Good morning, all of you. Are you able to hear me? Okay. Okay, what is the last thing I've done in class?
Ma'am, we will not be able to complete the chapter this week, right?
No, it won't be possible. Okay, melting and boiling point of cis and transforms, no? That means I've just started with geometrical isomers. Which was the last example I took? Butene, that's all. Okay, 1,2-dichloroethane. Fine. Okay, now after 1,2-dichloroethene, could you write the geometrical isomers for, say, hex-2-ene? Hex-2-ene. Did you get these two? What form is this form? Cis or trans? This is cis or trans? This is cis form. Because both the hydrogen atoms, similar atoms lie on the same side of the double bond. And here similar atoms are lying on the opposite side of the double bond. So this is a trans configuration. Which will be more stable, cis or trans?
Trans.
Yes. Trans is more stable because of minimum steric repulsions between the bulky groups. Which will have a higher boiling point? Which would have a higher boiling point here? Yes, cis would have a higher boiling point because of dipole moment of cis being more than the dipole moment of trans bond. So dipole-dipole interactions between molecules will be more in the cis one. So cis will have a higher boiling point. And melting point will be more for trans because melting point में क्या होगा? Symmetrical molecule trans ज़्यादा होता है. So trans का packing will be more closer. And hence trans will melt at a higher, Melting point will be more for trans, yes. Name this compound what I have written here. Give me the name of this compound. Yes, hepta 2,4-diene. Is it a symmetrical alkene or unsymmetrical alkene? Symmetrical means naming, numbering it from left to right. Is same like numbering it from right to left. Is it symmetrical or unsymmetrical? Yeah, this is unsymmetrical because this compound will have to be named numbered from this end only. You can't name it from the other end. So this is hepta 2,4-diene. How many geometrical isomers possible here? This would have how many geometrical isomers? Zero कैसे बच्चा? Five नहीं होंगे, 4 होंगे. 4 कैसे? You can have cis configuration here along with cis configuration here. So both the double bonds having cis configuration, that is one form. Then you can have cis at one, this double bond, and trans at this second double bond. That is the other form. You could have trans here and cis here, that is the third form. And you can have trans and trans configurations at both the double bond. See, I'm writing now. This is carbon 2, carbon 4, which have double bond. See, this is your C1. This is your C2, C3, C4, C5, C6, and C7. Now, what is the configuration at C2? Whether it is cis or whether it is trans? Yes, there is cis configuration here because both the hydrogen are lying on the same side of the double bond. What about C4? Is it cis or trans? Yes, there also it is cis. So the name of this compound now becomes 2-cis, 4-cis, heptadiene. This is one particular configuration. Now you can have could you tell me the configuration at C2? Yes, C2 is cis. And what about C4? C4 has trans. Very good. यहाँ पे दोनों हाइड्रोजन सेम साइड पे है, यहाँ पे दोनों हाइड्रोजन ऑपोजिट साइड पे हैं. So it is 2-cis.
4
4
trans.
trans, heptadiene. Could you tell me the configuration at C2? Yes, C2 is trans. And what about C4? Yes, C4 is cis. यहाँ पे देखो trans है, यहाँ पे cis है. So it is 2 trans, 4 cis, heptadiene. Sorry.
Both of them are trans.
Configuration here now. Both the double bonds have what configuration?
Trans.
Yes. Okay. So this will be 2 trans, 4 trans, heptadiene. So these are the 4 configurations of the molecule. Did you all finish writing? Okay, now here, this alkene, the diene was unsymmetrical. And I got 4 isomers for the diene, correct? Diene was unsymmetrical, I got 4 isomers. Both the double bonds having cis configuration, both the double bonds having trans configuration, the double bond at C2 having cis and C4 having trans, and vice versa. That means C2 pe trans and C4 pe cis. So 4 configurations possible. Now supposing I change this to a symmetrical alkene. This was unsymmetrical, I got 4. I'm changing it to symmetrical by removing 1 carbon. When I'm changing it to a symmetrical diene, now this is hexa 2,4-diene. Why do I call it symmetrical? Because numbering it from left to right is same like numbering it from right to left. Am I right? Can I say this molecule I can also number from the right to left? So this is a symmetrical diene. Numbering it from left to right is same like numbering it from right to left. That means viewing the molecule from left to right is same like viewing it from right to left. So now tell me, will the number of configurations still would be 4 or less than 4 or more than 4?
Mom, it still would be 4.
Viewing the molecule from left to right is same like viewing it from right to left. I'm just
We will
saying.
have 8.
You'll have how many?
8? No.
It will become more.
Okay.
No, that is my question. Is it going to become more?
It will become less.
So give me the number. Are these 4 configurations different? Viewing the molecule from left to right is same like looking at it from right to left. How many different configurations? Come on, tell me. See, now pay attention. If I look at this molecule from left to right, what is the configuration I come across first? I'm moving from left to right. What is the configuration first I'll come across? Cis configuration. And then what configuration? Again cis. Moving from right to left. What is the configuration here? Cis. Again this side also cis. So this molecule has cis-cis configuration from either side. Do I have anywhere else cis-cis configuration?
No, Mom.
No. So this is one particular configuration. Now see here. If I'm looking at it from left to right, I'm getting cis first and then trans. But what if I look from here, this end? What am I going to get here?
Trans.
And then cis. Do I have
Yes.
a trans cis configuration coming up?
Yes.
So can I say these two become same? These two are same. Why are these two same? Because अगर ये molecule को मैंने left से देखा तो पहले cis दिखेगा और फिर trans. But the same molecule, if I observe it from the right side, I'll see a trans configuration first and then a cis configuration. Is this understood? Which is this?
So
That
we will
means
have
these
3.
configurations have become same. Then here, If I view it from here, trans, and then go ahead trans. यहाँ से भी देखोगे तो trans and trans. Do I have anywhere a trans configuration? Any other place? No. So this is one particular configuration. In other words, both these double bonds could have cis configuration. That is one form. Both the double bonds could have trans configuration. That is the other form. Or one double bond having cis and the other double bond having trans. It won't matter whether this is having cis and this trans, or this is having trans and this having cis. Did you understand this? So now the number of configurations are 3 and not 4. Number of configurations are 3 and not 4. Have all of you understood this part? सबको समझा है ये? Because this configuration has become same as the other one. Any doubts still here? Can I proceed? Can I proceed? Yes, Aisha, only 3 isomers for that diene, because these two have become same. So you can have this configuration, and this configuration. Fine. This is a long molecule. Give me the name of this compound. Numbering should be from left to right or right to left?
To right.
And what is the reason? Because this will give you
Less
smaller sum
number
of low.
to-
Correct? So it's an unsymmetrical triene. How many geometrical isomers possible? 9 तो नहीं होंगे दिशा. Anyone else for the answer? नहीं, 7 भी नहीं होंगे. Yeah, okay, I'm waiting. No, not even 5. Total isomers here would be 8. 8 geometrical isomers. I'll show it to you. See, you can have cis configuration here. Simultaneously cis here and cis here. That is one form.
France, all of them. Then
That is
cis France.
You can have
cis
cis,
trans.
trans, and then cis here. You can
Yes.
have cis, cis, trans, cis, trans, trans. Likewise, now this I had kept cis here. Now I will change it into trans. Trans, cis, cis, trans, trans, cis, trans, cis, trans, and trans, trans, trans. So total configurations possible here are 8. I'll write 2 of them. You identify which ones I have written.
I missed out the 4th and the 6th one.
Oh.
This is the 3rd one. No, this is the trans. This is the second last one.
Yeah.
Cis trans.
Here you have trans configuration, here you have cis, and here you have trans. So it is TCT. Did you understand?
Yes, ma'am. The
What
first one.
Yeah, this is the first one, correct? Here you have cis configuration. Here again you have cis configuration, and here again you have cis configuration. So total possible configurations for this unsymmetrical trine is 8. I've just written 2 of them. Just copy these fast, and then I'll change this to a symmetrical trine, and then we'll see how many configurations we have. You all finished writing? Have you all completed? Okay. Now what if I change this to a symmetrical one? I can say change it to symmetrical one by removing one carbon. So if I remove one carbon, I'm going to get this. This is octa 246 trine. This is symmetrical. Numbering it from right to left is same like numbering it from left to right. So now again इनमें से जो configurations जो same हो गए हैं, that you tell me. I'm writing all all 8 first. You tell me which of these configurations become same. So I'll just remove those.
Fourth and fifth are same.
Very good. नहीं, fourth and fifth नहीं.
Sorry, fourth and seventh.
हाँ, fourth and seventh are same. If you see the molecule from left to right here, if you get cis, trans, trans, then right to left it will be trans, trans, cis. So trans, trans, cis same हो जाएगा.
Third and fifth.
Third and
Fifth. Cis, cis, trans, and trans,
cis,
cis.
cis, trans become same as trans, cis, cis. Any other things which are same, which are identical? Any other configurations? No, so now it will have 4, no, it will have 6, no? These are your 6 configurations. No? The molecule will now have 6 configurations, not 4. Did all of you understand this? Any doubts? What if I take this compound? Is it symmetrical or unsymmetrical? Symmetrical or unsymmetrical? Yes, this is unsymmetrical. I'll have to number it from left end.
Ma'am,
How many geometrical isomers here? हाँ बोलो.
ma'am, can you explain this octa 246 triene again?
This one.
Yes, ma'am.
See, when it is symmetrical means when you look at the molecule from left to right, it is same like looking at it from right to left. Am I right?
Yes.
So that means if I look into this configuration, cis, cis, trans, it is going to be same like trans, cis, cis.
Yes.
So trans, cis, cis I remove na from here. This needs to be removed because अगर left से देखा right में तो मुझे दिखेगा cis, cis, trans और right से left में देखा तो trans, cis, cis. So cis, cis, trans is same like trans, cis, cis. Got it?
Yes, ma'am.
Same way, then I could have this configuration to be same. Left to right, if I check, if I'm getting cis, trans, trans, right to left, I'll get trans, trans, cis. Trans, trans, cis needs to be removed now. Fine? Because
Okay,
these
ma'am.
two will be same.
Yes.
So remaining 6 configurations will be there. Number of geometrical isomers here. This is an unsymmetrical triene, similar to this one. Here I got 8. Will this have 8? Come on, tell me fast. How 7, Disha? This won't have 8, 7 because this part of the double bond will not show. It's a terminal alkene, no? The carbon has 2 hydrogen. If the carbon has 2 hydrogen, will there be geometrical isomerism on this double bond? You'll observe geometrical isomerism only here and here, but not here. Okay, terminating agar hai double bond, where the carbon has 2 same groups, that part will not show geometrical isomerism. Only these 2 double bonds. So you can have cis here and cis here. You can have cis here, trans here. You can have trans here, cis here, or you can have trans at both. Yes, now it has 4. See, I'm showing it here. What is the configuration here?
Both of them are cis.
Yes. Here now, what is the configuration?
Cis trans.
Yes. Likewise, you can have trans here and cis here, and you can have trans at both. So how many configurations for this compound?
4.
4.
Ma'am, I had a doubt.
Yeah, tell me.
In any compound, we start seeing the configuration from the below side. Like
Below.
the below one cannot be trans cis. It can be cis trans only, right?
Below one means?
How do I explain? Um, in the below structure, we can only name it as cis trans. Like okay, sorry, I got it. We seeing the configuration from left to right, so it will be cis trans.
Yeah. Now, even if you observe this molecule from right to left, it is not same like observing it from left to right.
Yes, ma'am.
Because ये unsymmetrical है. Are you all getting it or no? I don't know.
No,
Otherwise,
ma'am, I got it. I just got a little confused. I just had a
हाँ,
doubt.
नहीं, not about only you. What about the others? Others are also very silent today. Are you understanding? Okay. Can I proceed? So though this molecule has 3 double bonds, but can I say out of these 3, only 2 double bonds can show different configurations? The third one cannot, because the third one is a terminal alkene. Yes? Okay. So now could you tell me the number of configuration shown by this molecule? Again, this is unsymmetrical triene. Numbering यहीं से होगा. How many geometrical isomers here? Very good, Vedant. Yes, this will have only two configurations, cis and trans. Only this double bond can show different geometries. This one won't because this is a terminal. Neither would this because this carbon has two same groups, methyl and methyl. So if you interchange these two, it won't matter here. So these two double bonds cannot show geometrical isomerism. It will be only the central double bond. The central double bond here can have cis configuration. Or this can have a trans configuration. Did you all finish? Okay, all have completed. हाँ अभी ये दो तीन डबल बॉन्ड थे तो it was easy to answer. What if the molecule has, supposing I keep on writing double bonds, I go on adding double bonds, then how are you? Are you going to write and then get the answer? It will take such a long time. Am I right? So what I'll do is I'll give you a formula. Using that formula, you'll be able to immediately predict. 2 raised to number of double bonds. Okay, this is for, just write down for polyene. What do you mean by polyene? Polyene means more than one double bond. Okay. So write down. Say for example, if I have this compound. Can I say the ends of the double bond are, ends of the polyene are different? This end has a methyl group and this end has an ethyl group. Am I right? So number of geometrical isomers here is 2 raised to n, where n is the number of double bonds. Give me the answer here. It is 2 raised to n, where n is the number of double bonds. So 8. Did we? I did this example already. Did we get 8? See here, I've got 8. The two ends are different. Okay, the two ends are different. So we got 8 isomers. It is 2 raised to n, where n is the number of double bonds. N is the number of where geometrical isomerism is possible. What do I mean? N is the number of double bonds where geometrical isomerism is possible. Now let me take this compound. This compound also has its two ends different. So if I use this formula, will I get 8 isomers here? 2 raised to 3. Will I get 8 isomers here? I got only 2. So what am I supposed to take the value of n here? The number of double bonds where geometrical isomerism is possible. Is geometrical isomerism possible at this end? The left end? No. Is geometrical isomerism possible at the right end here? Again, no. So can I say only this double bond can show geometrical isomerism? So it will be 2 raised to 1, because only one double bond can show. 2 raised to 1, that means 2 configuration, that is cis and trans. Did you understand the first rule? All of you understood this rule? Okay, so now I'm going for the second one. Did you all finish writing this? Okay, so write down the second rule now. This rule you will use when the ends of the polyene are same. Ends of the polyene are same. That means something like this. The ends of the polyene are same. मतलब symmetrical डाइन लिया है मैंने. Again, this will have two cases. Two cases कैसे? When the number of double bonds are even, then the number of geometrical isomers is given as 2 raised to n minus 1 plus 2 raised to n by 2, sorry, minus 1. 2 raised to n minus 1 plus 2 raised to n by 2 minus 1, where the number of double bonds are even, like this one. So I'll write this here. Now this has even number of double bonds. It's a symmetrical diene. Numbering from left to right is same like numbering it from right to left. So I'll be using this rule now. And the number of geometrical isomers here will be how many? 2 raised to n minus 1. How many double bonds this has? 2 double bonds. So 2 raised to 2 minus 1 plus 2 raised to 2 by 2 minus 1. 2 raised to 2 by 2 raised to 2 minus 1 का आंसर क्या होगा? 2 raised to 1 plus 2 raised to 2 by 2. 2 by 2 is 1. 1 minus 1 is 0. 2 raised to 0. So 2 raised to 1 is 2. 2 raised to 0 is 1. So 3 isomers. Did we get 3 isomers for this? We got 3, no? We got cis configuration here. We got trans configuration here. And one double bond having cis and the other having trans. That is the third one. Okay. Did you understand this formula again? Okay, now what if the number of double bonds are odd? Then write down the formula. Number of geometrical isomers is given as 2 raised to n minus 1 plus 2 raised to n plus 1 by 2. Wait, I don't have space here. I think I'll use the curly brackets here. Arey. Like for example, I take this. Now here the two ends are same. And there are 3 double bonds which show geometrical isomerism. Okay. So the number of double bonds where geometrical isomerism is possible here are odd. So odd ke liye I will use this formula. 2 raised to n minus 1. N is a number of double bonds. There are 3 double bonds. So 2 raised to 3 minus 1 plus 2 raised to 3 by 2. No, 3 by 2, no, 4 by 2. Because n plus 1 hai. So 4 by 2 minus 1. 4 by 2 is 2. 2 minus 1 is 1. So 2 raised to 2 plus 2 raised to 1. 2 raised to 2 will give me 4 plus 2 raised to 1 is 2. So 6. Did we get 6 isomers for this? Had we got 6 isomers? Yes. Okay. So I think these formulas will be helpful for you. For these formulas you will use only when the ends of the polyene are same. So now any number of double bonds I'll give you. You should be able to predict. Now I'm giving you one question. You give me the answer for that. Just write down these formulas first. I'm writing a compound here. Just give me the number of isomers then. Give me the number of geometrical isomers possible. Yes, it's 10. Okay. So which formula you're supposed to use for this compound? This one. When the ends of the polyene are same, then it will be, and the number of double bonds are even. Even number of double bonds are there. 1, 2, 3, 4. So then you will be using this formula. Are you getting it? 2 raised to 4 minus 1 हो जाएगा. Plus 2 raised to 4 by 2 minus 1. So this will be 2 raised to 3 plus 4 by 2 is 2. 2 minus 1 is 1. So this is 8 plus 2. That will give me 10. Are you all understanding? Now are the two ends same for the polyene? No. So give me the number of geometrical isomers for this. Yes, it will be simply 2 raised to 4. Because 4 double bonds, so it will be 2 2s are 4, 2s are 8, 2s are 16. So 16. Have you all finished writing? Okay, I'm proceeding now. Next is geometrical isomerism in cycloalkanes. Name this compound. Just give me the name of this compound. Give me the name. I've already numbered it for you. Yes, it is 147 cyclodecatrine. Name this one, the other one. Yes, this is also cyclodeca 147 trine or 147 cyclodecatrine. Now, what is the difference between these two? They are geometrical isomers. I'll show it to you how. What is the configuration at this double bond, the C1? Does it look cis or does it look trans?
Cis.
It looks cis. Some say it looks trans. Okay, let me explain now. These two carbon atoms, they're what hybridized. Hybridization of these two carbon. Yes, sp2. So what geometry it will have? Trigonal planar. So one bond is like this. One bond is like this. Where should I write the third bond of this carbon? Can I say going upwards? Trigonal planar geometry. Bond angle 120 degrees, correct? Yes. Now, this carbon is also sp2. So one sigma bond is here, one sigma bond is here. What about the third sigma bond? Can I say it will be like this? Because sp2 hybridization, so trigonal planar. Both the hydrogen atoms, can I say they lie on the opposite side of the double bond? So what configuration is there? Trans. C1 has trans configuration. Let us see at C4. C4, again these carbon atoms are sp2. So one sigma bond like this, one sigma bond like this, the third one will be like this. So H is coming this side on the left side of the double bond. Again here, carbon is sp2, one sigma bond here, one sigma bond here, so one sigma bond will be here. Can I say both these hydrogen lie on the same side of the double bond? So C4 will have cis configuration. Coming to C7. This is one sigma bond, third one will be like this. One sigma bond, third one will be like this. Both the hydrogen lie on the opposite side of the double bond. So C7 has trans configuration. So it is trans cis trans configuration. Now here you tell me C1, C4 and C7. Their configurations respectively.
C1 is cis.
Yes, C1 is cis.
C4 is trans. And again cis.
So what type of isomers are these? Can I say they are geometrical isomers? Are you all understanding?
Yes.
Name of this compound? Can I say the name is same here? Yes. Give me the configuration at C1, C4 and C7. Yes, it is trans, cis, cis. So can I say all these three are geometrical isomers which I'm showing here? Fine? Yeah. Did you all finish writing these? This is cyclohexene. Will geometrical isomerism be shown by this molecule? What if I write the double bond here? Can I say anywhere I write the double bond here? This cannot show two different configurations in space. Yes, can अच्छा trans नहीं है तो cis नहीं होगा. Can it show two different configurations is my question. I place a double bond anywhere. Will it show two different configurations? No. So write down minimum number of carbon in a cycloalkene. Minimum number of carbon in a cycloalkene to show geometrical isomerism is 8. Minimum number of carbon in a cycloalkene to show geometrical isomerism is 8. So cyclohexene doesn't show geometrical isomerism. Cycloalkene mein geometrical isomerism starts from C8. Say for example, I take this. Could you give me the configuration here? Is it cis or trans? Yes, here it is cis. And here it is. Okay. So minimum carbon in a cycloalkene to show geometrical isomerism is 8. Did you all finish writing this? Is it done? Okay. Now write down Z and E system of nomenclature. I'll tell you what is this. Okay, now here this Z comes from the German word zusammen. Zusammen means same side. And E comes from the German word antigen. Antigen means opposite side. I'll tell you what is this. Don't worry. Name this compound for me. Yes, it is 1 bromo, 2 chloro, 2 fluoro, 1 iodoethene. Very good. Yes. Can this compound show two different configurations in space? In other words, can it show geometrical isomerism? Yes, it can. What if I interchange this iodine and bromine? Name this compound now.
Same name.
Yes, can I say same hoga ye?
Yes, ma'am.
Name is same. But can I say it is two different configurations of the molecule? In this configuration, fluorine and bromine are on the same side, and chlorine and iodine on the other side. Here, you'll have fluorine with iodine on the same side and chlorine and bromine on the other side. Correct? So these are two different configurations, but I can't name them as cis and trans because cis and trans is used only for what you say when you have two similar groups. But here all the four groups on the carbon having double bond are dissimilar. So for such systems, we use a Z and E nomenclature. So now let me explain how to apply this Z and E. For getting the name of the isomer as Z and E, we have to apply certain rules now. Those rules which I'm describing here are called as CAN, Ingold, Prelog rules. That is the CIP rule also it is called as. Now I'll have to apply certain rules to get the configuration whether it is Z or E. So I'm describing the CIP rules. Take the carbon having the double bond. Which are the two atoms bonded to it here? Iodine and bromine. Which is higher in atomic number? Iodine or bromine? Yes, iodine has a higher atomic number. The one having higher atomic number is given a higher priority. and the one having lower atomic number is given a lower priority. Now going to this carbon. This carbon also has two groups, that is chlorine and fluorine. Which is higher in atomic number? Chlorine. So chlorine gets a higher priority, fluorine gets a lower priority. Are similar priority groups on the same side of double bond or on opposite side? If the similar priority groups lie on the same side, then the configuration assigned to that is Z. And if the similar priority groups, same thing I'm doing here, similar priority groups here lie on the opposite side, so the configuration assigned to this is E. So this is the Z form of the compound and this is the E form. They are a pair of geometrical isomers. All of you have understood this part? Yeah, rules, let me just first explain, then I'll dictate everything together. Fine. You have finished writing the Z and E. What is the basis of assigning the priorities? On what basis have I assigned the priorities to the groups? Yes, atomic number. I'm proceeding ahead. Okay. Now again here all the four groups are different. I'm using the can ingold Prelog rule only to first assign the priority. Let me take this carbon. This carbon is directly joined to oxygen here and oxygen here. If the atom which is directly connected to the carbon having double bond is same, that means here like oxygen, both the oxygen are same atoms. Only if this atom connected to the carbon having double bond is same, then only you have to proceed to the next atom. Next atom here is hydrogen and the next atom here connected is carbon. Which will get a higher priority, carbon or hydrogen? Which has a higher atomic number? Yes, carbon will get a higher priority over hydrogen. You'll be applying this rule only if the first atom connected to that carbon having double bond is same. Let me take this carbon now. This carbon is also connected to a carbon here and carbon here. First atom is same. First atom is same, so now I'll proceed to the second atom. Second atom on this carbon are 3 hydrogen. Second atom on this carbon are 2 hydrogen and 1 carbon. Which will get a priority? 1 carbon with 2 hydrogen or 3 hydrogen atoms. See, I'll show it to you what I'm doing. I'll write it. First atom here was same, so I compared the second atom. Second atom here was hydrogen and second atom here was carbon. Now in this case, first atom is same, that is carbon again. Now the second atom. Second atom, I could take these hydrogen atoms. Hydrogen, hydrogen, hydrogen. These are the second atoms. Here it is hydrogen, hydrogen and carbon. So HCH. H, H, H. HCH will get a higher priority over HHH. So higher priority, lower priority. So similar priority groups lie on the same side. So the configuration here is Z. Did you understand this? Now let us see here. Carbon bonded to nitrogen, carbon. Which will get a higher priority? Nitrogen or carbon? Yes, N will get a higher priority, C will get a lower priority. Now coming to this carbon, bonded to carbon here, bonded to carbon here. So first atom is same. Now I'll proceed to the second atom. Second atom, here are 2 hydrogen and 1 deuterium. And here there are 3 hydrogen. Now atomic number to सबके same है deuterium और hydrogen के. When the atomic number is same, but when you're using isotopes, then isotopes के लिए then you'll be using atomic mass. Atomic mass you'll be using only in case you have isotopes. So the one with deuterium will get a higher priority over the one with hydrogen. Did you understand? Yes, okay. So this again is the Z configuration. Did you all finish writing this? Okay. Now let us see this compound. Let me take this carbon. It is bonded to a carbon here, again a carbon here. First atom is same. Now when first atom is same, I have to proceed to the next atom. Next atom here is a hydrogen and a double bond with carbon. And here there's a triple bond with carbon. So now what do I do? For a double bond, you need to double the number of atoms. And for a triple bond, you need to triple the number of atoms. So I'll just show it to you what I'm doing here. This is a CH double bond CH2. So what am I going to do? I'll write that hydrogen as it is. And now there's a double bond with carbon. So double bond with carbon means double the number of carbon on it. This carbon now, it is connected with 3 bonds to the other carbon. So you write the, instead of writing triple bond, you write 3 carbon on that. Did you get it what I did? Did you get this what I did? Okay. Now here, this carbon connected to a carbon which has a triple bond with nitrogen. Triple bond means you triple the number of nitrogen. And this carbon now has 2 hydrogen and 1 nitrogen. So now it becomes simple to assign the priorities, correct? ये राइट साइड वाले कार्बन में किसको प्रायोरिटी मिलेगा, इसको या इसको? Carbon with 3 carbon or carbon with 2 carbon and 1 hydrogen? Yes, okay. यहाँ पर this carbon is connected to 3 nitrogen and this carbon is connected to 2 hydrogen and 1 nitrogen. So 3 nitrogen will get a priority over this. So again, the configuration here is Z. Yes, a triple bond will get a priority over double bond. Yes, Vedant. Yes. I'm giving you one compound now, just now name it as Z and E. Give the answer to me as Z or E. Okay, how did you get Z? हायर प्रायोरिटी किसको दिया? कार्बोक्सिलिक एसिड और एल्डिहाइड. Yes, COH, higher priority, lower priority. Which will get a higher priority here? CH2CHO or CH2CH2OH? Yes, the CHO will get a priority. So again, the configuration here is Z. Did all of you understand this? Give me the configuration here. Is it Z or E? Cis to hai, but I want you to give me the answer in terms of Z and E. Yes. Higher priority, lower priority. Higher priority, lower priority. So this is the Z configuration. But we also know that this is also the Cis configuration because you have two same atoms. Okay. इसका जो transform होगा, that will have higher priority, lower priority, higher priority, lower priority, the E configuration. But always remember that Z is not always cis. Like if I take this compound. Give me the configuration here. Yes, the configuration for this will be E. नहीं E नहीं होगा, Z होगा ना. E कैसे होगा इसमें? ये हायर प्रायोरिटी है, ये लोअर प्रायोरिटी है. इसको प्रायोरिटी मिलेगा या इसको? यहाँ ऊपर वाले को मिलेगा ना. So the configuration is Z. But can I also write it as trans? Why trans? Because the two methyl groups lie on the opposite side of the double bond. So trans configuration. So remember, Z is not always cis. Z can also be trans. Similarly, E is not always trans. It can be cis also. जैसे इसका मैंने अगर ई कॉन्फ़िगरेशन लिखा, हायर प्रायोरिटी, लोअर प्रायोरिटी, this is higher priority, lower priority. This is the E configuration. But I can also write it as cis because two methyl groups lie on the same side. Are all of you understanding? Okay, now let us assign the configuration here. Of course, here bromine and sulfur, which will get a higher priority. Bromine will get a higher priority over sulfur. Now coming to this, pay attention here. First atom is carbon here. Here also it is carbon. First atom is same, so I'll proceed to the next atom. Can I say the next atom here are 3 oxygen? Why am I saying 3 oxygen? Because there's a double bond here. So double bond के लिए मुझे oxygen double करने पड़ेंगे यहाँ पर. So there are 3 oxygen. Here there are 2 hydrogen and 1 chlorine. Even though there is 1 chlorine, it will get a priority over 3 oxygen because atomic number of chlorine is 17 and atomic number of oxygen is 8. Okay, you don't have to add the atomic numbers of the 3 oxygen. Just single oxygen का atomic number इसके single chlorine atom से compare करना है. So chlorine will get a higher priority over oxygen. So here again the configuration is Z. Double bond bacha will not matter here. Okay. Chlorine will definitely get a priority over oxygen because chlorine ka atomic number is 17 and oxygen ka it's 8. You don't have to add the atomic numbers here. Okay. It's simply you have to compare chlorine with 1 oxygen. That's all. Did you all finish writing? Did you all finish writing? Now this is a diene. 1, 2, 3, 4, 5, 6, 7. Hepta 2, 4 diene. This is your first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. Fine. Now, what is the configuration at C2 and what is the configuration at C4? Cis है या trans है? Yes, this has cis configuration. These carbon atoms are sp2. So you know their hydrogen atoms would lie like this. Both the hydrogen lying on the same side. So cis configuration. Same way here also, both the hydrogen lying on the same side. So cis. So it is, you can write this as 2 cis, 4 cis, heptadiene, or you can also write this in terms of Z and E. Give me the answer in terms of Z and E. What is the configuration at C2? Will it be Z or will it be E? Yes, C2 will have Z. What about C4? C4 also Z. Yes, heptadiene. So here you can write cis or trans, or you can also write Z and E. One minute, I think इसका numbering उस तरफ से है. Give me the configuration at C2, C4 and C7. Sorry, C6. Okay, you're saying C2, C4 it is Z and C7 it is E. Okay, let us see here. I'm assigning the priorities using red marker. Now here this will get a higher priority, this will get a lower priority. Here there is a hydrogen here. And there's a, what you say, carbon here. So there will be higher priority and here hydrogen will get a lower priority. So the configuration here is Z. Very good. C2 pe Z hai. Now coming to C2 has Z. Now going to C4. C4 again I'm assigning the priorities. Okay. Chlorine higher priority, carbon lower priority. Here again carbon will have higher priority and the hydrogen here will have lower priority. So what is the configuration here? Again Z. Did you understand this? So the configuration here also is Z. Let us see the configuration at C6. Actually, you should put this. Chlorine here, carbon here. Chlorine gets a higher priority, carbon gets a lower priority. This is a hydrogen. Hydrogen will get a lower priority and carbon will get a higher priority. So the configuration here will be E. And then you will be writing the name of the compound. Did you get it till here how to assign? All of you have understood this part? Okay, I'll be continuing from here only in the next class. I am not yet done with this. Now, when ring systems are there, how you assign Z and E, that I have to do. Okay, so I'll be continuing from here in my next class. Homework. Okay, I'll give you some compounds here only. You assign the Z and E configuration to those. Just copy this as a homework. So assign the configurations to all the double bonds which I'm giving. I think 3 compounds sufficient. Okay. I'll be continuing next class. Disha, last class, I think I forgot to do the recording. I don't know. मेरे पास मिला ही नहीं. I saw it. I tried to get it, but Zoom पे था ही नहीं. वो मुझे mail आया ही नहीं था उसका. There was no mail, so maybe I didn't record or something. You remember me recording the last class? Then why I didn't receive the mail? I didn't receive the mail only in Zoom. Zoom का mail. पता नहीं फिर. Today's I'll send it. Okay. I can check on zoom.us. What do I have to add there?
You have to go there and log in, and there's a recording tab over there. If you click on the recording tab, it will show you recordings of those many dates.
Oh, fine. Let me try if I can do it. Fine.
Yes.
Oh. Chalo then, bye all of you. See you next class. I'm ending the lecture. You'll have copied this?
Yes.
Oh,
Yes, ma'am. Bye, ma'am.
bye.
Thank you, ma'am.